Hello, thank you for watching this video. So in this video, we're doing question 6 of November 2019 question paper mathematics paper 1, and the topic is financial mathematics. So I'll read question 6.1 statement and then answer the questions that follow. So let's go. They're saying two friends, Kuda and Tabo, each wants to invest 5,000 for 4 years. Kuda invests his money in an account that pays simple interest at 8.3% per annum. At the end of 4 years, he will receive a bonus of exactly 4% of the accumulated amount. On the other hand, Tabo invests his money in an account that pays interest of 8.1% per annum compounded monthly. Whose investment will yield better return at the end of 4 years? Justify your answer with appropriate calculations. Let's read this thing again. They are saying two friends, Kuda and Tabo, each wants to invest 5,000 for 4 years. Kuda invests his money in an account that pays simple interest at 8.3% per annum, right? At the end of 4 years, he will receive a bonus of exactly 4% of the accumulated amount. Tabo invests Tabo invests his money in an account that pays interest at 8.1% per annum compounded monthly. Whose investment will yield better return at the end of 4 years? Justify your answer with an appropriate calculation. 5. What they're saying essentially, we have two friends here, Kuda and Tabo. They're saying Kuda is going to invest his 5,000, right, in an account that pays 8.3% per annum simple interest, right? Yes. And at the end of 4 years, he will also be given a bonus of 4% of the accumulated amount. On the other hand, there's Tabo who wants to invest his money at an account that pays 8.1% per annum compounded monthly, right? For 4 years. So they're asking who will have money a better amount at the end of at the end of 4 years. So they want you to justify your answer by means of calculations. Are you with me? No problem. So this is 6.1. So what we need to do, it's more like we need to calculate the total amount that Kuda will have at the end and calculate the total amount that Tabo will have at the end of 4 years. And then compare the two. Whoever had more money is the one that will yield a better yield. It's the one that will have a better yield. Okay. So now for simple interest, let's start with Kuda. Start with Kuda here. So he invests his money on a simple interest, right? Which is your A is equal to P into 1 plus IN. Are you with me? Yes. So the accumulated amount is equal to the principal amount, which is the amount that he's investing, which is what? 5,000. Do you agree? Yes. Into 1 plus 0.083 times number of years, which is 4 years. Do you agree? So how much money will Kuda have? A is equal to the answer to this. What is the answer to this? So it's 5,000 into 1 plus 0.083 times 4. So it's at the end of 4 years, the account will yield what? 6660, right? So he will have this much at that simple interest account, right? But he's also promised to be given extra 4% of the accumulated amount, of this accumulated amount. So let's go and find that 4%. So that 4% of the accumulated amount will be equal to what? It will be 4%, which is 4 over 100, right? Times this amount, which is 6660. What is the answer to this? 0.0004. So what? It's 266.40. So this is how much extra he will be given as a bonus. Therefore, his accumulated amount for that account will be this 6660 plus 266.40, right? Therefore, your A is equal to the answer to this.
6926.
So what?
69.
He will have 6,926 rands 40 cents. So this is how much Kuda will have at the end of the investment period. So it's what he earned on that simple interest account plus the bonus of it, 4% bonus. So he will have this much at the end of 4 years. This is how much you will have at the end of 4 years. So let's go to Tabo now. So let's go to Tabo's investment. So he invested on a compound interest, right? So A is equal to P to 1 plus I raised N. So your P is how much he was investing, which is he was also investing in 5,000, right?
Yes.
Into 1 plus 0.081 all over 12 raised by the number of compounding periods. He invested for 4 years, right? But how, so he was gaining interest monthly. So how many times was he gaining interest monthly? It should be 48, because in 4 years, there are 12, in each year there are 12 months, so in 4 years there will be 48 months, which means he will gain interest 48 times, because the N is the number of compounding periods.
Yes.
Which is how many times do you get interest. If you're getting it monthly for 4 years, then you're going to get it 48 times. If it was monthly in a year, there are 12 months, so you're going to get it 12 times.
Yes.
Therefore, your A is equal to
6905
6905
.71.
So it's 6,971. Are you with me?
Yes.
So you see 692, 690. So Kuda's money will be more. You say, okay. Therefore, Kuda's how much? 6,910? 26, right?
6,926.
0.40 is greater than Tabo's what? 6,910? 5 cents, 5 rand, 71 cents. Therefore, Kuda will have better returns or investment. Because Kuda's money is more than that of Tabo. So he will have better returns on his investment. Are we clear?
Yes.
No problem. Now we move on to 6.2. What are they saying in 6.2? Okay, in 6.2, they are saying 9 years ago, a bank granted Mendy a home loan of 525,000. The loan was to be paid over 20 years at an interest rate of 10% per annum compounded monthly. Mendy's monthly repayments commenced exactly 1 month after the loan was granted. Let me read this thing again. They are saying 9 years ago, a bank granted Mendy a home loan of 525,000. This loan was to be repaid over 20 years at an interest rate of 10% per annum compounded monthly. Mendy's monthly repayment commenced exactly 1 month after the loan was granted. So, 9 years ago, Mendy was given a loan of 525,000, right? So this loan was to be paid over 20 years at an interest rate of 10% per annum compounded monthly. So Mendy started paying a month after the loan was taken. So is Mendy late or on time? She's on time, because if you take a loan and you are expected to pay monthly, you'll pay a month from now. If it was quarterly, you're expected to pay a quarter from now. Do you understand?
Yes.
If you're saying semi-annual, you're expected to start it 6 months from now.
Yes.
Fine. So if she starts paying a month later, she's okay, she's not late, she's on time. Right. They went on to say 6.2.1. They are saying now, Mendy decided to make monthly repayments of 6,000 instead of the required 5,666.36 cents. How many payments will she make to settle the loan? They are telling us that Mendy was expected to make payments of 5,066.36 cents. Are you with me? But instead, she paid more than she was expected to pay. She was paying 6,000 instead of the expected 5,066.36 cents. Do you understand that?
Yes.
Right. So they're asking how many payments will she be able to make, how many payments she will make to settle the loan, which means how many payments she will do or she will make to the bank to pay the loan. Are you understanding me?
Yes.
Fine. So if Mendy was expected, if she was paying 5,066 rand 36 cents, right? She was going to pay the loan over 20 years. Are you with me?
Yes.
Now that she's paying 6,000, she's paying more than expected. Do you expect her to pay at the same time, longer time, or shorter time? The duration of the loan. If she's paying more than she was expected, Do you expect her to finish the loan faster, or still on time, or longer?
Faster.
Yeah, she'll finish the loan faster because she's paying more than she should be. So, yeah, I think that makes sense.
Yes.
Okay. So, they're asking how many payments she will be able to make. Are you with me?
Yes.
Let's go. So, okay. This is a loan, right? So there's a current balance, there's an outstanding balance there, which is the present value of the loan. So your present value is equal to x into 1 minus 1 plus I raised negative n all over I. Are you with me? The present value of the loan is the balance of the loan. How much of the loan?
Yes.
Right? How much did you take? It's 510, 25,000. So the present value of the loan at the starting was 525,000. Do you agree?
Yes.
It's equal to x. How much is she paying? She's paying 6,000 instead. 6,000. So we expect the number of payments to be less than that 20 years.
Yes.
Right? 6,000 into 1 plus
1
plus 0 point 1 is 10%, 0.1 over 12 raised negative n, right?
Yes.
All over 0.1 over 12. So we're trying to find n. What is n? N is the number of outstanding payments. N is the number of outstanding payments. So you're saying if she's paying this loan, how many times should she pay? How many outstanding balance there is to finish this loan? Is this clear?
Yes.
Fine. Let's do this. So it will be, we'll cross multiply. This times this, it will be 5 to 5, right?
Yes.
Times 0.1. Okay, let me write this slide down. Because it looks like it's going to be 5 to 5. Times that, 0.1 over 12. Do you agree?
Yes.
This side goes over 1. This time this, you're left with 6,000 into 1 plus or 1 minus 1 plus 0.1 over 12 raised negative n. Do you agree?
Yes.
And then 1 to n, so divide by this 6,000 here. Divide by 6,000. This and that go away. What is the answer to this?
It's 35
35
over 48.
over 48, right?
Yes.
Then we're trying to solve for this. So take this to the other side. So you say subtract 1. 35 minus 1.
That's minus 13 over 48.
So minus 13 over
48.
48 is equal to negative into 1. Can you please press this as well?
It's 121 over 120.
All is negative n, right?
Yes.
So both of these things are negative.
Yes.
We divide both sides by negative 1.
Yes.
Do you agree?
Yes.
Okay. Then we want to take down this n. How do we take it?
We apply log.
Apply log. So we're going to say log of 13 over 48 is equal to negative n into log 121 over 120. Are you with me?
Yes.
Then 1n divide by
both sides by log.
negative log, because we want to get rid of that n,
Yes.
of that negative.
Yes.
Because 121 over 120 divide by negative log 121 over 120. Are you with me? This and this go away, the negative and the negative go away. Therefore, your n is equal to what? Whew.
It's 157.40.
So n is equal to 157.40. Right? So this is your n.
Yes.
So you wanted the number of payments, right? Fine. Which means how many times this person will pay into that account. You see this 157.
Yes.
these 157 are full 6,000 deposits.
Okay.
And then that 0.40, it was not a full one. It's just 0.4 of that 6,000.
Okay.
So in total, this person paid 157 6,000 into that account and paid and also a 0.4 of that 6,000, which is a 40% of that 6,000 as the last payment. So in total, this person paid 158 times because the full 157 in that proportion of that 6,000.
Okay.
Therefore, 158 payments were made into that account. So a total of 158 payments were made into that account. Is it clear?
Yeah, it's clear.
Okay. We move to 6.2.2. Okay, so now we're doing 6.2.2. They're saying, after making monthly repayments of 6,000 for 9 years, Mandy required money to fund her daughter's university fees. She approached the bank for another loan. Instead, the bank advised Mandy that the extra amount she repaid every month could be regarded as an investment and that she could withdraw this full amount to fund her daughter's studies. Calculate the maximum amount that Mandy could withdraw from the loan account. Let's read this thing again. They're saying after making monthly repayments of 6,000 for 9 years, Mandy required the money to fund her daughter's university fees. She approached the bank for another loan. Instead, the bank advised Mandy that the extra amount repaid every month could be regarded as an investment that she could withdraw, and that she could withdraw this full amount to fund her daughter's studies. Calculate the maximum amount that Mandy may withdraw from this loan account. So, do you hear what they're saying?
Yes.
They are saying that this lady now, she went, after paying for 9 years, she went to the bank and wanted a loan and applied for a loan. This loan was for funding her daughter's university fees, right? No problem. But then now, the bank advised you not to take another loan, but consider the extra amount that she's been depositing into that account for 9 years, right? As some sort of investment, right? As if she was investing into that account so that, there's some sort of investment that she can access right now. Do you hear me?
Yes.
So, if we consider those extra amounts as investments into that account, how much money did she have if she was gaining interest at the same rate as that was being charged for the loan? Do you understand?
Yes.
So, we need to take those extra amounts as if she was investing them.
Yes.
Right?
Yes.
So now they want to know now what is the maximum amount that she could take out? What is the value of that investment that she's been making for 9 years by those extra payments? So if we calculate the value of the investment, are we using the future value or the present value formula? We use the future value because we want to know what is the value of that investment if she has been paying for 9 years.
Yes.
So in that case, but we can say, okay, our future value is equal to x into 1 plus I raised n minus 1, right?
Yes.
All over I. So the future value, which is we want the money that Mandy wants right now.
Yes.
This is the monthly deposits,
Yes.
right?
Yes.
And that is the number of monthly deposits,
Yes.
and those are interest, of course. But how much has he put into that investment? So she was putting 6,000,
Yes.
but she was only expected to deposit 5,066 rand 36 cents. So the difference between the two is what she was investing.
Yes.
Because we can think of that 5,066 rand 36 cents as what was required by the law for the loan.
Yes.
But everything extra is just an investment.
Yes.
So we need to go and calculate how much is that extra and then put it into this account for 9 years. Is it clear? So our X, which is how much the extra that she was depositing, it should be the 6,000, right?
Yes.
Subtract 5,066 rand 36 cents. Therefore, your X value, which is the amount that she was putting into the account as extra, on how much was it?
That's 933.46.
933.4?
It's 64.
0.64.
Yes.
Which means this lady was putting an extra 933 rand 64 cents. So now, if the bank say consider this money as an investment, which can take you, it's not like you're investing this much for 9 years,
Yes.
right? So, and you earn for 9 years. What is it? How many months in 9 years?
In 9 years.
9 times 12. What is it?
9 times 12.
Yeah,
9 times 12. It's
108.
Yeah.
Right?
108.
So there are 108 months, which means she made 108 payments. This N is not the number of months, it's the number of payments, right? But since she's making those payments monthly, the number of payments and the number of months should be the same.
Yes.
In that case, we can just go and find the future value of that. So our future value is equal to 933, right? The x 0.64 into 1 plus I, which is, what is the percent? 0.1, right?
Yes.
Over 12 raised 108 payments minus 1 all over 0.1 over 12. Therefore, the future value is equal to the answer to this thing. So, what do we get? So, it will be 933.64 to 1 into 1 plus 0.1 over 12 raise what? Raise 100. So it's not 180, it's 108, sorry. Eight minus 1 over 0.1. How much did you get? I got 162,000.
Yes. 503.54.
162,510. 3 rands 51 cents. So this is the amount she will yield from her investment if she was investing 933 rand 64 cents for 9 years by making 108 deposits into that account. Do you have any questions for me?
No, I don't have.
Yeah, and I'm done here. And I hope it does make sense to you as it does to all of us here. Thank you for watching.